folks, my name is Ravi Prakash and welcome to the concept of relative speed, right? A super duper important concept in terms of time and distance chapter, and lots of questions are seen in every exams with this topic, okay? Relative speed. So lots of concepts are there. We'll cover each one of it. Okay, let's start it. Relative speed, right? So it is basically compared for moving objects, right? For moving objects, right? Because see, if I am standing, suppose this point here, if I am standing here on road and a car is moving at the speed of 60 km per hour in front of me, then this is the actual speed of the car, right? Then this is the actual speed of the car, right? There's nothing relative to it. I can say, okay, relative speed with respect to me is how much? 60 km per hour, but I am stationary, so this is the actual speed of the car. But in second scenario, if I am also sitting in a car, okay, if I am also sitting in a car, okay, and it is going with 40 km per hour, and another car is going at the speed of 60 km per hour, right? So in that case, I can't say, okay, the actual speed of car is 60 km per hour, but speed of this car relative to me is how much? It is 60 minus 40, that is 20 km per hour, right? Why 60 minus 40? Because in 1 kilometer, in 1 hour, my car speed is 40 km per hour. So in 1 hour I can move 40 km. In 1 hour they can move 60 km, the other car, right? That means the other car has moved only 20 km more with respect to me. That is relative to me, right? Not relative to a person, not relative to a person who is standing on ground. Who is standing on ground, in 1 hour this car has moved 60 km. But for me sitting in another parallel car, okay, moving in another parallel car, this car has moved only 20 km with respect to me. Okay, so there's quite a difference between relative speed and actual speed. Okay, so with respect to a moving frame of reference or with respect to same frame of reference, right? Frame of reference means whatever frame of reference I'm taking, right? For this car, there are two frame of reference I discussed. One is on ground. A person is on ground, so frame of reference here is ground. Okay, with respect to ground, that car is moving at a speed of 60 km per hour. Then okay, fine. This speed of car is 60 km per hour. Okay. In second scenario also, speed of car is 60 km per hour, but I am now judging in another car which is also moving at 40 km per hour. Okay. So in my respect, that car is moving at a slower speed, right? Not actually 60. In my respect, because I am also moving at 40, this car is moving at 60. This car is moving at a speed of 20 with respect to me. With respect to me, this car is moving at a speed of 20 km per hour. Okay. This car is moving at a speed of 20 km per hour with respect to me. Extra 20, right? So this is the meaning of relative speed. Very, very important funda. Okay. So whenever you see two bodies, right? One body is moving at a speed of x km per hour and another one is moving at a speed of y km per hour, and both are moving in same direction. So this is same direction, right? So when both are moving in same direction, so relative speed is basically y minus x or x minus y, remember, whichever is positive, right? You have to take positive value. Okay, so it is y minus x or x minus y, whichever is positive. That means what I'm saying is difference of two speeds. Difference of two speeds. Whichever is positive, right? Difference of your two speeds. Okay. So when two bodies are moving in same direction, what is relative speed? That is difference of two speeds, right? I told you why. One train is moving at a speed of 100 km per hour. Okay. You are sitting in just another train which is running parallel to the track, and your train is moving at 120 km per hour. Okay, that means your train is faster than that train only by 20 km per hour. So a person sitting in that train, right? A train is moving at 100 km per hour, and your train is moving at 120 kilometer per hour. So for a person sitting in this train, it seems like this train is going slowly ahead. For a person sitting in this train is going slowly, ahead by 20 kilometer per hour, right? Because your train speed is 120, that also is 100. So in 1 hour you will move 100. Sorry, in 1 hour you will move 120, and he will move 100, right? So only 20 kilometer ahead of that train. Okay. So with reference to a person sitting in that train, your train is moving at extra speed of 20 kilometer per hour, right? This is the meaning of relative speed. Okay. What happens when bodies are moving in same opposite direction? Okay. So when bodies are moving in opposite direction, take an example. So there's a car moving at 60 kilometer per hour, and there's another car here moving at a speed of 90 kilometer per hour. Okay. And gap between these two car right now, the gap between these two car is, let's say, 500 kilometer. So what will happen? In 1 hour, this car will move 60 ahead. Okay. And in 1 hour, this car will move 90 ahead. Right. So gap was 500. Now the gap is after 1 hour, right? So after 1 hour, gap is reduced by 150 kilometer. That is 90 this car has moved, 60 this car has moved, right? So 150 kilometer. So this is addition, right? So it seems like just right. Suppose two cars are coming. Okay, so one you are driving a car and another car is coming from front. Okay, so with respect to you, right? If you assume that you are at a stationary point, right? So with respect to you, that car will seem at double the speed. Okay, that means your car is also moving at 60. That car is suppose moving at 60. So it seems like that collision will take place at the rate of 120 kilometer per hour. That is 60 plus 60. You will seem like it, right? Suppose for another example, suppose you are sitting in a train. Okay, many times it has happened. You're sitting in a train window side. Okay, you are going at certain speed. Let's say your train is going at a speed of 100 kilometer per hour. Okay, suddenly you are like relaxing near the window, and suddenly another train comes from opposite side, and it suddenly shaked, right? Suddenly you are very feared, or suddenly you are shaken, right? It seems like that train has come really fast. Okay, still the speed of the train is still 100 kilometer per hour. Okay, but you are also going at 100. It is also coming at 100, right? So for you it will seem like suddenly speed has become 200 of your train, right? Your train has become really fast. Okay, with respect to that train, if you will see that train, right? If you see the ground, you'll see, okay, ground is stationary. That means my train is going at a speed of 100 kilometer per hour only. Okay, but if you see only that train, your train will move. You seem that my train is moving much faster. That is your speed plus that train speed. Right? This is always true. Okay. So whenever you're sitting in car also, right? Suppose you are always only watching the moving object, right? When you're sitting in a car or a train, right, and you are seeing the another object that is also moving, you're not watching any stationary object, right? Suddenly you will feel that if it is in opposite direction, it is doubled, right? Same that relates to this first one, right? In your train, you are sitting in your train. Your train is moving at 100 kilometer per hour. Another train is running in parallel track at the same speed, 100 kilometer per hour. Okay, so if you just watch that train and nothing else on the no ground and all, you just watch your train and your train and the other train, right? You will see you'll feel that your train is stationary. You are stationary. You're not moving because you are moving. That other train is also moving at the same time, right? So you don't take the reference, right? Where has your train reached or how much your train has covered? No idea because you're just watching the other train. So your train, wherever your train is, that same point, another train is also there, right? So that means that difference you can't mark out. Okay, this is the meaning of relative speed. Relative speed means with respect to a moving object, right? With respect to a moving object. If it is with respect to if it is with respect to a stationary object, then that is the actual speed. Right? So This is the meaning of relative speed. Okay. So ultimately all the conclusion I will draw, right? Hope you got everything. Okay, so all the conclusion I draw to mark these two things. First thing was, if two bodies are moving in same direction, right, what is relative speed? Difference of two speeds. Okay, if two bodies are moving in same direction, x kilometer per hour and y kilometer per hour, what is relative speed? That is x plus relative speed here is relative speed here is, right, this is the case of opposite direction. This is the case of opposite direction. So relative speed is x plus y kilometer per hour, right? That is the sum of two speeds. That is the relative speed. Okay, so this is the whole concept behind it, right? Now one more very important concept. This is about speeds. This funda is about the speeds, right? Now next I'll do about lengths. What about lengths, right? Relative speed. Now with respect to lengths of objects, right? Length of objects, right? Very important point, right? See, relative speed with respect to length of objects, right? Very important. Okay, listen this very carefully. Okay, see, when there's a platform here, the cases I'll discuss, right? First case, when a train is a train of length L, okay, trying to cross a platform. There's a platform of length L1. Okay, so let's say train length is L1 and platform length is L2. Okay, so when train completely cross, right, when train completely crosses the platform, right, so what is the distance covered? So distance covered is what? So you see, any point take, suppose you take up any point here, right, like this is the rear end of train. So first, this is just at when the train is just at entry mode in the platform, right? Just in the entry mode in the platform. Okay, right here, just in the entry mode in the platform. Very important concept, very important. Just in the entry mode. Okay, so now you see, this whole of train will first come on platform and then completely cross each other, right? That means this, suppose what is the case when this train, right, when this rear end of the train, okay, when this rear end of the train comes here, okay, that means the train comes here. So train becomes something like this. Okay, this is a train now. So train from here comes here. This is a case of what? Completely cross, right? Take up any point to understand, right? Take this rear end. So rear end from here, this rear end, then this point R. From R, it travels from here to here. This R has come from here to here. What is the distance it traveled? So this length of train, that is L1 plus platform length, this is L2. So when it completely crosses, the total length is what? L1 plus L2. The total length is what? When a train completely crosses a platform, the total length is what? Total distance covered. Okay, completely crosses. So total distance covered, right? So total distance covered. Total completely crosses. So total distance covered. Total distance covered is how much? L1 plus L2. Fine. Now take up next case now. For the case of moving object now. This is train L1 and this is train L2. Train with length L1, this is train with length L2. Now, when they completely cross each other, what is the total distance to be covered now? When they completely cross each other, what is the total distance to be covered? Right. So you see here, Now, when train is just right, when this their front end are just like there's no gap between them. This is the case, right? When front end are just like this. So when a train completely crosses the other train, right? So this is what we're talking about relative speed, right? So relative distance, what I'm talking about, right? This I'm talking about relative distance, not the actual distance. Okay. So relative distance. What is the no, what is the what is the uh, what is the relative distance? Okay, relative distance. Okay. So you see here, this is point L1 here, this is point L1, this is length L1. Now suppose you're sitting at this point in a train. Suppose you are as a person sitting on this point. Okay. So when relative distance means, or with respect to relative speed means, what has happened with respect to a moving object, that is with respect to you. You have to observe, right, what has happened with respect to you. So best point to observe is what? Suppose you are sitting at the rear end of the train, right? You are sitting here. Okay. What will you see now? From a window you can see it. Okay, that train is at a length distance of L2. That means in your respect, you have to see that while coming to this train, you have to first cover the length of your own train, that is L2. So distance covered should be how much? Distance covered should be L2, first thing. Okay, to reach the front end of this. Okay, now when situation becomes like this, the first train is like this, okay, and second train is like this now, and you have come here. Okay, so you have come here now. This is L1 length, this is L2 length. Okay, so now you see that, okay, now you are at the back end of your train, and that in front part are now same. So you know that, okay, I have covered distance of my train length, that is L2. Now I have to cover another train whole distance, whole length. I have to cover another train whole length to cross that train, right? That means I have to further cover a length of L1. So total distance covered by me is how much? L1 plus L2. Total distance covered is V by L2 plus L1, or L1 plus L2. Right, very important point. When two trains are coming in opposite direction also, from the moment when their front part is same, right, to completely cross, they have to cover distance of L1 plus L2 with respect to you. This is what? This is what? This is relative distance. This is relative distance. This is not exact distance. This is relative distance. What is happening with respect to you? Okay. Same case will happen in third case when two trains are coming in opposite directions. Sorry, same direction. First train length L1 crosses second train of length L2, completely crosses. Okay. So again, suppose now you see this train. Now this is a situation. Front end and back end are just in the same line. No gap absolutely. From this point, suppose you are at this rear end. So if you are at this rear end sitting here, what you will see, the other train is at a distance of L1 from me. That is the length of my train. Okay, so other train is at a distance of L1 from me. So first you have to cover a distance of L1 to to reach the back part, right? That means let's say this is the situation here. L2 has reached the train, this is train length L2, and you have come here. Your train length is L1, and you have come here, right? You have come here. This is the next situation. You have come here now. Now so you know that you have now covered a length of L1. Now to completely cross, you're seeing that, okay, now you are at this back of that train, and your train is faster, so you have to completely cross that train length. You have to completely see that train, right, from back end to front end, right? You have to completely see that train. Okay, you have to completely see that train from back end to front end. That means total length covered by is how much again now? L1, L2. So again, when two trains completely cross each other, so total distance covered is what? L1 plus L2. Right. So this is very important concept, right? Maybe you can see as a formula in the book, but you will not never know the concept, right? This is a concept. What is happening? What is happening with respect to you? You assume anywhere at the point of a train, right? Best point is the back end of the train. If you are the back end of the train, you'll see that the other train is at a distance of L1 from me, and then when I reach there by covering distance L1, the other distance again L2 whole I have to cover. So total distance covered by me is what? L1 plus L2. L1 plus L2, right? Very important point. So in all three cases, right? In all three cases, no? in all three cases, total distance covered when two trains or train or platform completely crosses is L1 plus L2. That is the summation of both the lengths. Summation of both the lengths, right? Super important point. Now we can do few questions based on this. Okay. First question, we'll see. Very easy one, I hope. If a length of a train and platform are 500 meter and 700 meter respectively, find the time taken by train moving at 54 kilometer per hour to completely cross the platform, right? So simple situation it is. There's a train of length 500 meter. It has to cross a platform of length 700 meter and speed of train is 54 kilometer per hour, right? So since it is in meter, you have to change it in meter per second or the other points in kilometer, right? Your wish, right? It's quite easy to change anything in kilometer per hour to meter per second. 54 kilometer per hour is 54 kilometer by hour. 1 kilometer is 1000 meter and 1 hour is 3600 seconds. Okay, you cancel it, you get 5 by 18. That means multiplying any data, very point, multiplying any data, kilometer per hour into 5 by 18 will convert to meter per second, or it's reverse. Meter per second into 18 by 5. Just try unitary method. Simple cross multiplication. 18 by 5 will give me kilometer per hour. Will give me kilometer per hour. Okay, because 1 kilometer is 1000 meter and 1 hour is 3600 seconds. So on cancellation it gives 5 by 18. So you can simply remember kilometer per hour into 5 by 18 changes to meter per second, right? So here also I can change this one, 54 kilometer per hour. Okay, so 54 kilometer per hour into 5 by 18. 18 cancels 3 times, so it is 15 meter per second. That means the speed of train is what? It is actually 15 meter per second. So what is the time taken? So what is time taken? Time taken is distance by speed. Time is distance by speed. Distance to be covered is what? Always L1 plus L2. I told you, always L1 plus L2 divided by speed. What is L1 plus L2? 500 plus 700 divided by 15. Okay, so 1200 by 15, that is 80 seconds. So 80 seconds is the answer for this question. 80 seconds is the answer for this question. Okay, 80 seconds. Move to next question now. Now, two trains of length 150 meter and 250 meter run on parallel lines. Okay, so the length of 150 meter is one train length and other train length is 250 meter. They run on parallel lines. When they run in the same direction, it will take 20 seconds to cross each other. Okay, so in same direction. So I again know that in same direction, what is time? Now, for two moving object, okay, time is obviously distance by speed, but for two moving object, always write time is distance upon relative speed. Right? So that relative term is there in the mind, right? So was the distance covered? Always when completely cross. In case of completely cross each other. Okay, that is how much? L1 plus L2. Right, that is 150 plus 250 divided by relative speed. Okay, so let's say one train, I don't know the speed, right? So let's say one train speed is x meter per second and the other train's speed is y meter per second, right? So right now I don't know that which is the faster and which is the slower train. So let it be x minus y, or it could be y minus x also, right? Just keep in mind. Okay, x minus y is the relative speed. Okay, and what is the time taken? It is time taken how much? It is 2 seconds, right? Sorry, what is the time taken? Yeah, it will take 20 seconds to cross each other when they're in same direction. Okay, so this t is 20 seconds now. So what you can write here from is t is 20. So x minus y, or you can write like this here. Just see. 20 is equal to 400 by x minus y. Therefore, x minus y is equal to 20. This is the first equation, right? Difference of the speeds of two trains is 20. Okay, now second equation I can write for opposite direction. Quickly you can write. Same thing, time is distance upon speed. Okay, so right now I have to take in terms of relative speed. So relative speed is what? It is, sorry, yeah, I have to take in terms of relative speed. It is what? Distance by time. Distance is how much again? 400. 150 plus 250 upon time. What is time here? Time is 5. Time is 5. This is 80. Right. Therefore, and what is relative speed in this case? It is how much it is? X plus y, right? It is x plus y. So x plus y is 80. This is the second equation. Quickly can solve it. X plus y is 20. X plus y is 80. Adding 1 and 2. Adding 1 and 2. Simply add it. 2x is equal to 100. Therefore, x is equal to 50. So if x is 50, difference between both is 30. So y is equal to 30 meter per second. The speed of two trains are 50 and 30. Okay, 50 and 30 is the speed of two trains. Okay, I hope it is clear, right? So all these concepts you need to build up, right? Speed will come, right? This is very easy question actually. Once you solve 2-3 more questions, this will look very easy, this kind of question, right? And do it just mentally. That x plus we have sum of difference of speeds is 400 by 20, that is 20. Sum of speeds is 400 by 5, that is 80. So x minus y 20, x plus y 80. 2x is, so x is 50. Right, so you can do it very easily, this kind of question. Okay, just understand the concept right now. Okay, now we'll cover next question in the next video. Thank you.